Hi to all. So in this short recording, we're going to cover the pricing of a call option using a one-step binomial tree. So this is going to be simple. I'm going to summarize this, or I'm going to walk you through a couple of steps, right? And before we even start, I would like to highlight what are these steps. So the first step in to get this price using this single this one step binomial tree is get the intrinsic. I'm going to write everything in very simple terms. So get the intrinsic value of options in the two states of the world, right? So by now you're probably familiar. There's a good state of the world for the stock and a bad state of the world for the stock. Second, get the probabilities. So we already saw in the previous video how we can get these probabilities of the stock moving up or the stock moving down. Once you have then the probabilities, we will get the expected value of the call option in I'm going to call this period t plus 1 because it can be 1 year from now, it can be 3 months from now, it can be depending on how the problem or the question is set up. We can assume we can assume different settings. And finally, we're going to get the present value of this expected value from step 3. So I'm going to write here 1, 2, 3. These are the 4 steps. And let's work with each one of the steps. So the first step is get the intrinsic value of the options in the two states of the world. So in the good state of the world, the stock moves up, it goes from 40 to 60. Then the call option will be worth, we can get it using the intrinsic value formula, which is the max of stock price in this good state of the world minus strike or zero. And we can do the same for the call option in the bad state of the world, and we can get that doing max of stock price if the stock moves down minus strike price or zero. And therefore, yeah, because the stock price is below the strike price, basically this is and this call option has an intrinsic value of zero. And this is what we know as when an option has an intrinsic value of zero. This is what we know as an option that is out of the money, basically, right? So it's not in the money. So now that we have the intrinsic values of the options in the two states of the world, let's get the probabilities. And how can we get the probabilities? In the previous video, we saw that the formula for the probabilities is simply 1 plus r minus t divided by u minus t. So we need to get the probabilities. Let's get the probabilities, and let's do it here. So in order to get the probabilities, we need to the value of u and the value of d. And in the previous videos, we have seen that the value of u, we can get it by dividing the stock price in the good state of the world. So if the stock price goes up, it goes up to 60, right? So this 60, we divide it by the stock price today. And down is the stock price. If the price goes down, this is 30, and then this 30 we divide it by the stock price today. So u is 1.5. Once again, I just said it, I'm gonna say it again. If you multiply 40, the stock price today, by u, which is 1.5, you end up with the stock price in the good state of the world, which is 60. 40 times 1.5 is 60. If you multiply 40 by 0.75, you end up with the stock price in the bad state of the world, right? 40 times 0.75 is equal to 30. Once we have U and D, the risk-free rate that we need in the formula, this 1 plus R that we need in this formula, we are given that information. So now the probability, we're going to get it in the following way. 1 plus the risk-free rate, 1 plus the discount rate, the risk-free rate minus down, and then we're going to divide this by up minus down. And then let's remember, just it is always good to get that numerator in parentheses, right? So now we have this probability that this, what is that probability that the stock price will go up, and we know that the probability that the stock price will go down is simply equal to 1 minus this. It's the rest, right? So if we have a 40% chance that the stock price moves up, in the 60 out of 100 cases, uh, then we will have the stock price. If the stock price is not moving up in 40% of the times, then the stock price will be moving down 60% of the times. Now, after we have this, we just copy what we already calculated here. Call up is the call price in the good state of the world is 15, and the call value in the price in the bad state of the world is 0. And finally, we can calculate the call price today using this formula, which is the call price today will be probability of the call price being in the good state of the world, or stock price moving up. So P, I'm going to write this in this whiteboard because I think it's going to be a little bit better. So the call option price today will be equal to probability of stock price moving up. So if stock moves up, then the call price also moves up, multiplied by the call price in that good state of the world where the stock moved up, plus 1 minus P. So that's basically the probability of the bad state of the world, right? And then this is the probability, this right here, of the good state of the world. I'm just going to write good state. And then, so we now have probability of the price moving up multiplied by the price of a call option if the stock price moves up, plus the probability that the price of the stock conversely moves down multiplied by the call option price if it moves down. So far, that's the expected value. And then, so whatever this expected value is, we just divide that by 1.05, 1.02, 1 point, depending on what the risk-free rate is. So 1 plus R. In some problems, you will usually find 5%. So that's why in most cases you will just divide by 1.05, right? But you need to pay attention to what is that rate, because it's actually, we need to divide by 1 plus R. So now I'm going to go back to the Excel, and we can conclude using that formula. If you have not taken note, just go back and take note of that formula, and then we're going to use it here. So it is probability of the stock moving up multiplied by the call option if the stock price moves up, plus the probability that the stock will move down multiplied by the call option in that setting, in the bad state of the world. And if we just stop it there, this is the expected value of the call option in the period 3 months from now, 1 week from now, whenever this at the end of this step in the tree is. And then what we do is we get this whole thing and we divide it by 1 plus R. And by doing that, we are getting that expected value first, and now by dividing by 1 plus R, then this result is now the present value of the expected value of the call price, and that is the call price, which is 5 point, according to the binomial model, 5.714, and we can just make that shorter. It's just 5.71. Okay, so I'm hoping this is helpful. Very quickly, I think this is going to help if we are working with a put option, for example. Then we can do this fairly quite fast, and let's follow the same steps. I'm going to copy these steps from here. So if we follow the same steps, the first step is get the intrinsic values, right? In the case of a put option, remember the formula is max of strike price minus stock price, or zero. So we just type this here. And of course, if stock price moves up and it moves up above the strike price, this is out of the money. So the put option price is zero. And then we do the same here. Strike price minus stock price if price moves down, or zero. And then we have this intrinsic value of 257. Now, let's get U and let's get D, because the second step, get the probabilities, we need U and D. We need the up and down factors. So what is the U? It is just the stock price when it in the good state of the world divided by the stock price today, and down is just the stock price in the bad state of the world divided by the stock price today. Finally, if you watch this the earlier part of this video, you have the formula of the probability, so we can use the formula of the probability here, which is basically 1 plus r minus down, and then we close all of this numerator in a parenthesis, and then we divide this by up minus down, and that is probability of the stock price moving up in this particular setting. And then 1 minus p, if we do 1 minus this probability, of course, if the probability of the stock price going up is 0.77%, then the probability that the stock price will move up is just the opposite, is 0.23, and that's what we see right here. So after we have this, then we can copy these values, which we already calculated, right? We can just copy them there. And then what is the put price? I'm going to delete this. The put price, and let's keep in mind, it will be probability of the stock moving up. Therefore, our put option is in the good state of the world for the stock, but that is a bad thing for a put option, because in the good state of the world for a stock, you do not make money with a put option, right? So we multiply this by the price or the value of the put in that good state of the world for the stock. The stock is going up in value, so the put option is going down in value. So we multiply this by zero, and then plus 1 minus p, or in other words, the probability that the stock will go down, and then we multiply that by the price, or by the value of the put in that bad state of the world. So once again, when you are in the bad state of the world for the stock, your put option is getting value, so you're gaining from holding a put option if you are holding in that put option. So far we just have p up times the value of the put in the up, the good state of the world, plus p down, plus the value of the put in the bad state of the world for the stock. So we have one last step, which is the fourth step. We need to take this whole thing in a parenthesis and then divide this by 1 plus 5%, and we end up with the put price today. So we have calculated the price of a call option, and we have calculated the price of a put option using a binomial tree, as long as we only have one step And in the following video, we will also cover how to solve a two-step binomial tree. Okay, thanks for your attention. I hope that this is helpful once again. Take care.